Hello guys, today we'll discuss lead code question number 8 to 7, making a large island. So in this question we are given an n by n binary square matrix which has 0 and 1. So first of all it is binary, so it obviously has zeros and ones. Also in this matrix we are allowed to change one 0 into 1. For example, in this matrix one cell is marked as 0, so I can change that to 1. Now after doing this operation, either doing it or not, we have to find the size of the largest possible island which has all the ones. Okay, let's make an example here. Let's try to do an example. Let's say I have this island. Okay, uh, like this. Okay, let's make one very quickly. Okay, like this. Okay, we have this island. Now in this island we have ones and zeros. Let's say this is 1 0 1 0 1 0 and so on. 1 0 1 1 1 1 1 1 0 0 and so on. Okay, so one of the islands here, as you can see, is this, right? This is one of the islands. Also this is also one island. So if I change this 0 into 1, if I change this 0 into 1, so the new island becomes this, and the entire thing, right? This. So we have to find the maximum area of such island in this entire matrix. Okay, so now how can I do this? Okay, one of the solutions that can be here is that we can mark all the current islands with some color, and then I will iterate through the entire matrix, and just check if the surrounding ones have size or not, and what are the colors, and then I can progress from there. Okay, let's first complete this matrix. 1 0 1 1 1 1 1 1 0 0 0 1 0. Okay, this is also 0 0 0. Okay, let's say this is our matrix. Okay, now what I will do is I will iterate through all the ones and just flood fill that island with some color, and also find the size on the way. Okay, let's say I am at this one. Okay, if I am here, I cannot go to anywhere else, right? Because this is the only one, and we can only move in these directions, right? 1 2 3 4, north south west and east. Okay, so the size of this island is 1. Okay, great. Now the size of this island. Okay, this island will be this. I will just use the flood fill and just find the size and also color all these elements. Okay, great. So here the size is 1 2 3 4 5 6 7, right? So I will just mark the size as let's say 7. Okay, I will use some different color here. 7. Okay, nice. Now I will move to some other one. Let's say this one. I have arrived at this one. Okay, now I will do the same and just color this into some different color. Let's say this color, so it will be like this island will be this. Okay, and we'll also find the size and just put that size into each cell here. Okay, great. This is also one of the islands, this is also one of the islands, and this is also one of the islands. This, let's take some other color like this is also one of the islands. Okay, great. Now here we know the size. Okay, let's say this color is peach or something. This looks like this, right? This is brown. Now brown has a size of 1 2 3 4 5 6 7 8 9. Okay, great. Now this blue has a size of 7. Now this color, let's mark it as pink instead. Let me do it clearly. Right, this is pink is 1, orange is 1, and this is our, let's say, cream. This is cream white. This is also 1. Okay, great. Now we have found the sizes and we have also assigned the color to each one. Okay, what should we do now? I will again iterate through the entire matrix and just find zeros. Okay, let's say I am at this 0. Okay, let's say I am here. Now for this 0, how many ones it is surrounded with? 1 2 3. And how many colors it is surrounded with? Only 2, this blue and cream, right? So here it is blue and cream. Okay, now for this 0, if I change this 0 to 1, all these islands will be connected, whichever color surrounds this 0. So that will be 7 plus 1. 7 plus 1 plus this exact cell also, so we will also add 1. It is 9 then. Okay, I will just compute one of the answers, right, which is 9 in this case. So one of the candidates for answer is 9. Again, let's say if I am at this 0, it has only one color surrounding it, so it is 1. So the answer will be 1 plus 1. The cell itself will be also counted, so it is 2. Okay, nice. If I am here, okay, if I am here, okay, no, if I am here at this cell, the only color that surrounds this cell is 1, is brown, and the size is 9. So the answer here will be 9 plus 1. Similarly for all these zeros. Okay, in the end I will just pick the maximum of all these values and just return the answer. Okay, so this is our algorithm. It will take a prior knowledge of DFS, flood fill algorithm, and that's pretty much it. So I guess let's begin the implementation for it now. Implementation is going to be a bit lengthy, so be with me on this journey. Let's begin. So n will be not size. Now we will need a, also first let's split screen so we can see the diagram as we go along the implementation. That will help us greatly. Yep, looks nice. Okay, we have the n, our grid is n by n, so we don't need the size of the column because both are same. Now we will need one matrix which will tell whether any of these cell is already visited or not. Okay, also we need two more indices to store the color and the size of the island of each cell. Like let's say for this one, the color will be brown and the size will be 1 2 3 4 5 6 7 8 9, right? So the size will be 9 and the color will be brown. Of course we will not use brown or a cream or blue here. We will color code them through numbers, so it's starting from 1 2 3 4 and so on. Okay, why don't I just copy this? we will initialize the colors with -1. Also same for size, also initializing the size with -1. Okay, we have made these. Now we need a function to perform flood fill algorithm. So let's make a lambda function here. This function will return the size of any island, and also mark the cells as visited, so we don't go to that cell again in future. Let's say DFS. Now here we also need to check whether these coordinates I and j do not go outside the matrix, like I becomes less than 0, or j becomes less than 0, or more than n, more than or equal to n, right? So to check just that, we will make another lambda function which is called OK. Yep, we have made it. Now before going to any cell, first we will check whether it is inside the matrix or not. If not, or if it is already visited, I will simply return 0. Okay, great. Or also if I accidentally go to any cell which has value 0, so it is not any island, which is not the part of any island. Yep, we have done that. Now I will just start. First of all, we will mark the cell as visited, so we don't go to it again in future. Yep, we have done it. Also, so we will just simply return 1 plus dfs of I plus 1 comma j. Let I will just copy this, I comma j plus 1, I minus 1 j. This will give us the size of any island simply. This is a simple recursion, so it's pretty obvious and pretty clear. Now next function that we need is to color these and also assign sizes to all of these cell to any island. Okay, so we will just make function set size and color. If it is not okay, let's just put this. Also, if the color is if the color is already set, right? So we will not set it again. If color, okay, we have done that. Now I will just set the color and size S. Color is also C. Now I will just do this for the other cells also. Mm. 2 to the 4 directions. This is also done. Now let's begin coloring the islands through using these functions that we have just made. Iterating through all the cells. If any cell is 1 and it is not visited in previously. I will just first fetch the size. Size is DFS I comma j. Okay, great. Now I will set this size and color. Also for color, now we will start assigning color and the implementation for that. So implementation integer color. Let's name it as C. Okay, which is initially 1. Okay, set size color I comma j and size is sz and color is C. Yep, this is done. Now what we need to do is we have to make this map also, right? Like this. Like for cream we have size 1, for brown we have size 9. So to do this we can use a hash map. So let's make map size of color. Okay, we have done this. Size of color C is equal to size and C plus plus in the end. Now if I have colored one island, I'll just do this C plus plus and then assign any other island with a new color. So here color means C, integer C simply. Okay, great. Also this function DFS will mark all the ones in the island as visited, so we don't come to this island again in future because we have already computed the values for this island. Okay, great, we have done this. Now I can start. Now till now what we have done, let's discuss that first. Okay, till now we have marked each island with a unique color. We have also marked each cell with the size of the island it is in. Okay, like here one, for this cell we have marked the value 7. Okay, and the color is blue. Similarly for all the ones in the entire binary matrix. Next step would be we will iterate through all the zeros. Okay, we will iterate through all these zeros and just check how many islands surround that 0 and just add the size of all these islands and then plus 1 for that cell itself. That will be the candidate for our answer. Let's do that. This loop is needed again, so just copy paste that. Also before doing this, here in question it says that we can change at most 1 0 to 1, which means that if we are not changing any 0 to 1, any island will also contribute to the answer. Okay, the answer will be this integer. Now this size itself is also a candidate for our answer. So answer is equal to and size. Okay, now we can safely just iterate through all the zeros. If it's 1, we are not interested in it. Okay, great. Now we are iterating through all the zeros. For any zero, we will just check how many islands surround it. To get that, we will use a set surrounding colors. Nice. If we will first check the left cell. Okay, if grid, if first, if the left cell, if the left cell even exists, if okay, I comma j minus 1 and grid, and if it is 1, okay, surrounding colors dot insert color of that cell. Now just do this for all the 4 sides. Also minus 1 here, plus 1 here, plus 1 here. Yep, we have done this. Now answer will be maximum of answer. Oh, integer surround sum. This will be the sum of the surrounding areas of all the islands that surround that cell. Initially that's 0. Now iterating through all the islands for auto SC surrounding colors. Surround sum plus equal to size of color of SC. Now we want the size of this color, so I will use the hash map that we made earlier. Surround sum, we have done this. Now answer will be max answer comma surround sum plus 1. Yep, we have done. Now simply return the answer and just check whether this works or not. Oh, there's some syntax error that I missed. Okay, this is done, it's okay, it's also okay. Let's run. Yep, we got all the test cases accepted. Now let's fetch some input cases from the discussion section also. Here we are testing for more test cases before submitting. We got all the test cases accepted, so we can confidently submit the code now and hope it gets accepted. Yep, it got accepted. So let's just summarize the approach yet again for even more clarity. So basically what we will do is we will just find the size for each island and assign one color to each island. Here like this is one of the islands. I will assign a color which is like, say, let's say blue, and the size will be 7 for this island. That can be found using floodfill or DFS floodfill algorithm. Same case for here also. We got a color, we assigned a unique color to each cell of this island and the size. Same case for these islands also. Now after this, I will iterate through all the zeros and just check how many islands are exact neighbors of that cell, and just take the sum of all the sizes for this island and just add one to that, because we are also changing this 0 to 1. Now after that, that will be a potential candidate for our answer. In the end, just we'll compute all the possible new islands and just return the maximum out of them. This is the algorithm. Now for this, let's try to compute time complexity. Okay, so time complexity is, this is n square, this is n square. Okay, now this is, now for each cell, I am going to each cell exactly once in this loop, right? I am going to each cell exactly once, and I am not computing any cell again and again, because I have used is the visited array. So this is also n square, looks n square to me. So overall time complexity is n square, big O of n square. Now for space complexity, it is also n square, because these are all two dimensional matrices of size n. So it is also n square. So time complexity big O of n square, space complexity big O of n square. So this was our algorithm, and this was my approach to solve this. Please drop down any discussion, any doubt, or any new ideas you might have in the comments down below. And thank you so much. We will meet with the new solution later. Thank you. Bye.